Hello, my name is Selena Hall. I will be presenting the first semester of my capstone project called the Quarantine Fish Tracker. This capstone project satisfies the COT6931 computer science project at the University of West Florida. This is the first semester of a 2-semester-long capstone project. The client is a marine biologist at Reefscapes, a family-owned and operated business that designs, installs, and services aquariums. This company also sells aquariums, aquarium supplies, corals, live rocks, fish, and other aquatic species. Live species, once received from suppliers, are quarantined for a period of time before joining other aquatic species. During quarantine, the fish are given preventative medications, and the water chemicals and temperature are checked daily and adjusted as needed. The quarantined fish survival and mortality rates are tracked using a Microsoft Excel spreadsheet, a flat file. On separate sheets, the supplier and client treatment events are documented. Paper logs are used to track the water quality in each aquarium. There are multiple problems identified with this current system. All the data is not integrated in one area, and since some data is not electronically stored, the data is therefore not being utilized and is not available for analysis. Not all the data is being tracked, such as the aquarium each fish is in. The client is currently unable to analyze possible causes of fish mortality from the current tracking system. She performs a biopsy on the fish to announce cause of death, which can only rule out disease. There are multiple causes for fish mortality. Fish survival can be affected by disease shipment from the supplier, sickness, stress, unfavorable conditions, and lack of shelter. The client is currently unable to prevent fish mortality based on current data collection methods. The objective of this project is to provide a better method of data entry, data storage, and data analysis in order to track the quarantine aquarium fish survival rate and to include water quality levels and preventative medications, as these factors may also play a role in the fish survival rate. The data will later be used to analyze fish survival and mortality rates and possible causes of death. It will also be used to track trends seen in fish mortality. The scope of this project is to replace the current spreadsheets and paper log. This will replace the current form of data storage. This project will also provide a means to input and store discrete data that can be used for data analysis and reporting. The time span of this project is 8 months, which is 2 semesters. Any additional requests outside of this project scope will not be included in this project at this time. Here are the goals of the project: to create a SQL Server database with tables storing data on fish type, water quality, treatments, quarantine events, shipment events, distributors, aquariums, disease, and client treatment events. To create user interfaces to input quarantine fish data, to input daily water quality test results, to log client treatments, and to view, query, and run shipment reports, to analyze data, to find any trends, and create reports and charts for the client to access. The course requirements for Semester 1 includes the following artifacts: a project definition, project schedule and timeline, a project budget, software project management plan, software requirement specification, software design document, weekly project status reports, project reports, PowerPoint presentation, video presentation, and a Semester 1 project report. The project topic is the quarantined aquarium fish survival rates. The research of this project includes understanding the needs of the client, the current deficiencies, the level of technical knowledge of the users, the type of data to collect, and what data to report. This project will satisfy the requirements of the COT6931 Capstone project and the needs of the client. The deficiencies identified currently include the use of a single computer at reefscapes. The test and production environments may vary slightly in hardware, understanding marine biology subject matter, availability of the client, the availability of the company computer for access during implementation. The audience includes Tracy Osh, the marine biologist, and Professor Lohr. The project methodology I will be using is the prototyping approach. The project schedule and timeline will be documented using the Gantt chart. The schedule is divided up into the phases of the software project management plan, which are acquisition, initiation, requirements, planning and design, implementation, testing, deployment, and project closure. This semester covered the project phases initiation, acquisition, requirements, planning, and design. Next semester, I will complete the planning and design phase with completing the user manuals and test plans, and will begin the implementation phase. Using this chart, I am able to calculate the hours and effort and the estimated cost and actual costs. This spreadsheet includes separate sheets for the project plan, budget and expenses, communication plan, issues log, risk log, change request register, metrics, and milestones tables. On a separate sheet is the budget and expense plan. The project budget summary shows the estimates of the expenses. A separate table shows the weekly estimated and actual expenses, which are calculated from the project schedule sheet. The client time, Professor Lohr's time, is also included in the budget summary. The man-hour rate is $30 an hour. The software and hardware requirements include Microsoft SQL Server 2012, Microsoft Visual Studios 2012, Microsoft .NET Framework 4.0, IIS must be enabled, external hard drive for backup storage, computer to install the database. The project design consists of the database server, the application server, and the web server. The database design uses a Microsoft SQL Server database to store and query data, to assign roles and manage users, to store user passwords which are encrypted, to run reports and analyze data. The application design includes web-enabled user interfaces used to view data, add new records, update records, edit records, delete a record, search and query data, and run reports. Microsoft Visual Studios 2012 will be used as the integrated development environment to create these components. The user interfaces will be created using the ASP.NET web form, and coding will be in Visual Basics. SQL will be embedded in the code when accessing, writing, reading, updating, deleting, and querying the database. The configuration file and the GUI design will use XHTML. The web server that will be used to publish from Visual Studios 2012 is the Internet Information Services. Here is a high-level architectural diagram of the Quarantine Fish Tracker project. The user accesses the login page on their browser via the computer and internet. The user can recover a forgotten password or register a new user. If they are a member and are successfully logged in, the welcome page will open. Here the user can select which log they want to use. All logs will allow them to return to the welcome page or log out. All logs read and write to the database. This is a relational database that comprises of 3 tiers: the shipment tier, the event tier, and the lookup tier. The shipment tier has a one-to-many relationship with the tables in the event tier. The table in the shipment tier is called shipment. The event tier is the second tier and has a many-to-one relationship with the shipment table. In other words, there can be multiple events for one shipment, but there can only be one shipment for each event. The tables in the event tier have a one-to-one relationship with the tables in the lookup tier. The event tier tables are quarantine event, client treatment event, and water event tables. The final tier is the lookup tier. Tables in the lookup tier have a one-to-one relationship with the tables in the event tier. The lookup tables are only related to the event tables, but are not directly related to the shipment table. Hence, to link the shipment table, you must join the event table. Here are the lookup tables: distributor, fish, tank, treatment, and disease tables. This is the database model diagram for the quarantine fish tracker. The three tiers and the relationships are clearly demonstrated in the diagram. The diagram consists of the following tables: shipment, quarantine event, water event, client treatment event, distributor, tank, fish, treatment, and disease tables. The diagram shows the primary keys, foreign keys, and all the fields in each table. Here's a diagram to depict the functional use cases. Once a user is logged in as a member, the user can select a GUI to view. Here the user can search, add, edit, update, and delete records. They can also view data in the grid, sort data in the grid, and run reports. The client system manages the local application data and communicates with the server. The server system is where the users and the data are managed. The server system communicates with the client. The component requirements include a login page, password recovery page, new user registration page, welcome page, quarantine fish log, aquarium log, client treatment log, shipment totals log. All GUIs, except for the login, password recovery, registration, and welcome pages, will feature the following functions: add, select, edit, update, delete, search, return to welcome page, and log out. Here is a detailed components UML class diagram. All the attributes and methods are included under each class. Here is a concise diagram showing the user will start at the login page. If the user is not a member, they can register. If they forgot their password, they can recover it. Once successfully logged in, they will be viewing the welcome page where they can select a desired log below. The next slides will show the main GUIs: login page, the welcome page, and the 4 logs. This is the login GUI. This will be the first user interface the client will view. Once the user is successfully logged in, the welcome page will open. The welcome page is where the user can select which hyperlink to go to. The user can also log out from this page. This is the quarantine fish log. Data can be added, deleted, updated, and viewed from here. The aquarium log is used for the daily water testing. The client treatment log is for documenting any client treatments. These fish are usually off-site and not in Reefscape's quarantine aquariums. The user will be able to start a record and come back to it on a later date to edit and update the record. The shipment totals log is used to view the shipment events and the totals calculated. User will be able to run queries and reports from here. The Quarantine Fish Tracker project is my first computer science project using ASP.NET and IIS. One of the lessons learned when working on my project design is I highly recommend taking the software design class to assist with the design aspect of the project. I did not take this course as it was not a requirement, but would have been valuable for this project. I found this phase, planning and design, challenging and made a change in my methodology from the waterfall method to prototyping. Prototyping helped me greatly with the design, but is more suitable for a small-scale project similar to this. I found that creating a project plan and schedule very helpful. The schedule must allow adequate time for tasks in the project plan, or else it makes it difficult to stay true to it. Communication is vital in any projects. Communicate with the client and professor frequently. Always refer to Dr. Laura when there are any questions about the project requirements. Last but not least, stay within the defined project scope and plans to keep from any diversion. It is very easy to get sidetracked. Use your plans and schedule to stay on track. The next semester will end the planning and design phase with the completion of the user manual and test plan. It will also begin the implementation phase shortly afterwards. Thank you for your time, and I hope you enjoyed this presentation.